At just very quickly, Archimedes at its core is a software engineering guild, and the guild is curated by alums from ThoughtWorks, Accenture, IBM. It is a guild for some very specific reasons. That was this, say, an agency or a consulting company or a marketplace, which I'm not going to get into necessarily now because we don't really have the time. But at a very high level, our focus is to enable members from the software engineering community that we've curated to engage, to grow in their careers, to engage with each other in both passion projects as well as potentially professional projects, and then provide them with avenues to monetize their skills. When someone comes through into the guild, we generally band them at a particular for a particular skill at a particular level, in terms of where their skill level lies as it relates to a skill set. And that banding generally involves, at least at the levels from apprentice through to coder. Hello. I think someone is talking. May need to mute. Sorry. But yes, so basically that banding happens at the apprentice through to the coder level, not necessarily for the higher levels of the guild, where people generally come in largely through a referral system that we've refined over time. In terms of how companies can access the guild, they can access the guild through a variety of different ways, but the two most common ways are code, which is a task-based code as a service platform that we've built, as well as through a hiring mechanism where they can hire members of the guild to come work with them on an interim, as well as a fractional and or a full-time basis. That's as much as I'm going to talk about Archimedes now. Don't want to spend too much time on this. This topic is really about Ken and MLOps. So I would like to hand over to Ken at this point, maybe with a quick introduction, Ken, on yourself, your background, and then going into the topic at hand and how you see, honestly, the entire ecosystem around this playing out, because it's a new topic to many, and everyone here is extremely interested in it, I'm sure.
Great. Yeah, thanks so much, Mohammed, and I really appreciate the opportunity to talk to the group today. Thanks so much for the gracious invitation. MLOps is a topic I've been really immersed in for really about 3 years, 2.5 years. My background is I spent a good deal of time at several very large software companies managing large engineering organizations. This was a good stint at Adobe, a stint at Atlassian before I really decided I wanted to throw my knowledge and experience and sort of where my career was going into the new space of AI and ML. And this is a great starting point kind of conversation, because I think what I've looked at and what I saw as I moved into this part of the industry was that really machine learning in particular is beginning to transform the way we build software. And so really for everyone who is a software engineer at any level, from an entry level, somebody straight out of university, or entering the market from a non-traditional sort of avenue, or senior leaders, people who are managing large software organizations or IT departments across any industry, machine learning is here, and it's a part of your ecosystem, and it's something that your company and your software is going to need to deal with. And I find it just really fascinating to look at the transition that we need to make from the really very mature processes that the industry had developed over 25, 30 years around building commercial software of different types, originally sort of desktop and multi-platform desktop applications, moving into the cloud, moving into really global, networked service kind of architectures. Companies have really refined how do we do that work. And there's a lot of best practices. There's a lot of tooling and capabilities. And the ML sort of machine learning aspect of this challenges some of those, and it creates gaps and issues that we have to navigate. And it becomes almost fitting a square peg in a round hole at times. And so really, this is a topic I'm extremely interested and passionate about, and it's great to have an opportunity to talk to you. So I'll go ahead and share. I have a few slides. I think, I have probably 20 minutes or so worth of talking to you. If you have a question as I'm going along, it's fine to interrupt if something's unclear. I'm happy to sort of field that as we go, but we'll definitely have a chunk of time at the end as well for Q&A. So let me go ahead and get my screen shared. Okay, so folks seeing this all right? Great. Okay, so we'll dive right in. And the way I want to talk about MLOps, and sort of from a 101 perspective, I want to talk about it from the point of view of DevOps, because most of us are more familiar with DevOps, and we've either worked in an organization or in a team that use some DevOps principles or tooling and capabilities. And I want to help use that as the framing to then talk about where does MLOps diverge from that, and in what way is it different, or what way is it the same? So that's what I'll kind of do throughout the talk today. And hopefully that's helpful to begin to kind of form this picture of where does machine learning fit into the overall software development lifecycle. So the first thing I wanted to do is just level set a little bit on what I'm thinking about when I say DevOps. So there are a lot of different elements, components. There are different points of view about what is and what isn't DevOps. The way I kind of look at DevOps is, yes.
I think you're the speaker notes version of the
Okay,
slide deck showing. Sorry about that.
No problem. Let me go back out. Let's try this. No, it's still going to presenter view. Hold on a moment.
Yep, that will.
Oh, did you have it there?
Yep, that, whatever that
okay.
Was definitely work. Yeah.
Right, and then I'm going to go.
You can go to the presenter view. That would work.
There we go. Is that better?
Yes, Ken. Thank you.
Yeah. Okay. Great. So in terms of DevOps, I think there's two. I want to divide it into two aspects of the way I think about DevOps. So one is, what are the objectives? Like, what are we trying to accomplish when we look at a DevOps approach or mindset? And the four objectives that kind of stand out to me are listed here. I really think that DevOps has been about a progression over time of software engineering organizations to say, look, it's better for us to iterate on smaller changes to our code base more quickly, as opposed to sort of the counterpoint of waterfall development, where you do major changes, you spend a lot of time building, stabilizing, and you don't really release for a long time. And you do it in these big kind of chunks. DevOps is first and foremost an iterative model, and saying that we believe in the fact that smaller changes tested and delivered more quickly will be of higher quality. And the really important part of that from a quality perspective is early defect detection. And so because you're iterating more quickly, and because things are being delivered incrementally, you find the challenges or the problems, the things that are wrong with the code as you go along much more quickly. And that is always far lower cost to fix. So it's that iterative development, and it's the ability to find your defects early. In order, sort of underpinning the ability to really do that, what we discovered and what really sort of brought DevOps to the fore was when we identified that, hey, there are consistent and repeatable processes and automated tools that will help us actually do that quick iteration, and will help us be able to go from ideation to building a piece of software to delivering it to the customer very quickly. And then they kind of added on after a little bit after that initially, and as folks really thought about this from a strategy and an approach perspective, we recognized that, well, in order to really iterate quickly and find defects fast, you also have to have really good monitoring. You need to be able to get feedback back into the development team very quickly. And so that, by stitching that whole process together, we get to a point where you have faster iteration, you identify your defects very quickly, and you put the product in front of the user. So you not only see defects, but you get user feedback very quickly. And there's a whole industry built around leveraging user feedback and speeding up this iteration and streamlining this process. And so I think it's important to kind of anchor around those objectives and understand, like, when we talk about DevOps, that's a big part of it. Now, nested inside of those objectives are a whole lot of tactics and tools and activities that we do to sort of serve those objectives. So there's automated test, synthetic testing, all of those kind of tools and techniques all along the pathway of a software project that allow you to very quickly. Continuous integration, when you scale up to a larger piece of software that involves multiple components, multiple teams contributing, becomes very important that you're able to actually very quickly and in an automated way integrate that full product and ensure that all of those components interact properly together and are stable. And then continuous deployment, that's the piece of automating the processes of putting the product in front of the user, right? And in the cloud, in a cloud services base, in a Kubernetes or other kind of hypervisor world, this has become much more possible than it was years ago. And it's a very important piece of being able to get that feedback and identify, here's how we move quickly. I threw feature flagging in here and kind of in quotes, because once you get out to a deployed product, a big part of being able to iterate very quickly is the ability to separate deployment versus delivery of the software. Right. And so if you've worked in a sort of high iteration, high speed DevOps kind of world before, you understand that we build small pieces of software, we deliver them all the way out to production systems, but they may not yet be a full-fledged feature or a feature we want to unveil to the whole user base. We may still be doing portions of that work elsewhere. We may want to preview it with a subset of users. We may want to test it against the existing sort of feature and functionality versus a new feature functionality with actual users. So that's all part of this continuous feedback space. And there are some critical mechanisms that are needed to be able to enable the team to navigate and really get the most value out of that feedback. So I've included feature flagging here. I don't know if it's always elevated to this level, but I find it a critical piece of being able to do software with feedback. Monitoring observability, logging, the capability of understanding how the product behaves once it's deployed, and being able to do that continuously and see how things change, part of DevOps. And then this last one I've kind of thrown on here as a bit of an afterthought, but I've seen it sort of discussed as a key part of DevOps. I'll be quite honest with you, I'm a little conflicted whether this is really DevOps or something else, but there is some relationship to a full-fledged DevOps process and a more microservice type architecture. So a decomposed, componentized software architecture. So there seems to be some relationship. I don't know if they're exactly demanded of one another per se, but I think it's worth pointing out here that generally speaking, when you have a fully realized DevOps solution, you're usually working in a more componentized type code base. And you'll find real challenges if you have a very large monolithic application to really fully realize the value and the intent of DevOps. So I just sort of point that out as an aspect of what we talk about when we think DevOps. So having kind of anchored that, I want to talk a little bit then about what are the differences? Like, how does machine learning operations differ from DevOps as a basic sort of function? And I've kind of identified there's maybe 4 areas. I will say the first one is a little bit, I kind of waffled whether there's really a first one or not, but I want to talk about it. It's not exactly a clear difference between DevOps and MLOps, but I think it's worth looking at. The other 3 are areas where MLOps has challenges and activities that are materially different than just a traditional software application. And I want to go into a little bit of that and try and give you a sense of what are these things that are different from MLOps versus DevOps. So I'll talk briefly about the first one. So in machine learning, what's usually happening is we are building a machine learning model, we tend to call it. And you can think of a machine learning model generally as a piece of software that ultimately its job is to take in data and produce some result out of that data. And it's usually a prediction, it could be a categorization, it could be a set of predictions. And so there is some sense that it's it has utility in that you give it a set of data at runtime, and it can give you some insight into that data and some decision out of that data, essentially. That generally means that when we talk about the unit of work in machine learning, which is a machine learning model, it usually is best to think of it as a component. It's not really an application of its own in most cases. Now, there are some very simple use cases where you might slap a very simple kind of UI or API on the front of a single ML model and get a single prediction. Now, sometimes it's something like, maybe I want to have a little application that predicts the price of a house that I want to sell, right? And this is a common example, and I'll use this through a couple of these where, we have a whole bunch of data about house sales in an area from the past, historical data, and you can build an ML model that basically uses that data to determine what's a good prediction of a particular house's future price, right? And so that's kind of very transactional. It's like, you're going to give it the information on that house. It's going to give you back, here's a price, and it's probably going to tell you, here's the level of confidence that we have that price is accurate, right? So in most cases, when you think about it in an application context, most applications now are going to include interacting with one or more ML models as just a part of the overall activity of that application. If you're a bank, for example, or an insurance company, maybe, you may have an application that your agents use to determine things like, I'm working with a customer who wants to buy insurance. What's the level of risk of a particular payout that would happen to this customer? Well, your application needs to do lots of things like create a customer record. It needs to maintain communications with that customer. It needs to gather a bunch of data from maybe lots of different systems about that customer. That's not machine learning. It's just general application development. But within that application, at some point, it's going to pass that data to a machine learning model and get back maybe a risk score that tells the agent, this particular user falls into some band of risk, and that changes the price of the insurance, for example. Right. So kind of a simple example. So I think the important piece I'm kind of pointing out here is that DevOps generally applies to both activities around building a component, but also kind of building an entire application that you're delivering. MLOps, we're going to see, is mostly focused on the unit of work of the ML model. And so I'll talk a little bit about how those might mesh together later in the talk, but that's all that's sort of here. The other three areas I'll go into a little bit more detail, which is, we need to understand what training of an ML model is. And that's an activity that general DevOps systems don't understand or deal with. Where does that fit in the process, and what is it? We need to understand that ML applications and ML models are developed using a different kind of developer tools often. So sometimes different languages, but also a different paradigm of development. And that impacts the way that we automate some of the processes, we automate integration with things. So it's worth understanding a little bit of what those are. And then finally, there is a separate and distinct set of additional monitoring that's necessary when working with machine learning that is kind of distinct from typical application monitoring. And I'll sort of highlight some of the key areas there and talk about those. So before we jump into those three difference areas, I just wanted to do a quick stop on saying, from a language and sort of terminology perspective, in machine learning sort of applications, we have three different types of data that we generally talk about, or maybe classes of data. They're not really types, but you have training data, and training data is historical data. Like in the example I gave, it's data that already exists of what already happened that we're going to use to train a machine learning model how to make decisions about what a future outcome might be. And so it's kind of it's often thought of as somewhat static. It's a chunk of data, oftentimes very large amount of data, that we use during the preparation and development of an ML model. It is something that does need to be refreshed, and I'll talk a little bit about retraining in a few minutes, but just know that there's that class of data. We then talk about model data. Now, model data is essentially a single set of data, oftentimes in a file format of some kind. It can be fairly large for an ML model, but model data is essentially the outcome or the output of a training activity. And what it is essentially a set of weights or numbers that are applied to the machine learning algorithm when we use it to do inference, right? And so it's kind of this intermediate point, and it's an important part of the machine learning model as an application or as a component. It's almost like part of the code of that component. But it's dynamic. It can change over time. It doesn't change during the use of the model, but when you refresh the model, the only change you might make is I now have new model data. All the code is the same, model data is different. That model will behave differently, right? And so it's important to understand that, and we'll talk a little bit about where that fits in the DevOps workflow in a minute. And then finally, there's inference data, and this is the data that's being passed in essentially. And what we're doing there is saying, hey, inference is the activity of using the ML model to get a prediction. I've acquired some data and I want to use that model to get a prediction. Inference, we put in the inference data, and that's essentially just the input. Okay, so I'll talk about training briefly. So training, essentially in the process of developing a machine learning model for use in an application, there's a stage of that process that is separate from testing. You're still going to do testing, right? You still have traditional type testing, in fact. But before you test, we need to do training. And training, you can think of a little bit as an automated code development activity. This is part of getting to the functioning component of a machine learning model. And training is simply taking that historical data, we run it through a set of algorithms and mathematical processes that teach and generate the model generate a set of model data, which essentially is used by the code that implements the ML model to be the smarts, essentially. And this is really the artificial intelligence part of the machine learning model, is getting to that model data. And the way we get to that model data is using algorithms against a set of training data, right? There are a wide variety of tools that automate this process. And there are sort of standard algorithms of various kinds. There are different frameworks, PyTorch, TensorFlow, et cetera, that are really about facilitating a data scientist conducting this training activity. There are essentially these three different parts of this, which is you've got to manage the data. So you've got to get a set of training data. And that often involves both acquiring the data, but also manipulating it a bit. So there's data processing and cleanup. They're sort of putting it into a frame that works best for the algorithms they're going to do the training. So there's some data manipulation that goes on here. And that's an important part of what the data scientist is doing when they're building a machine learning model, is really getting a good, accurate, correct training data set. And then there's the algorithms themselves that do the training. And so there are tools and platforms that do this for a data scientist. And then the last point I'll make here is, and I kind of alluded to it earlier, that the model is really only as accurate as the training data was. And so as you put a model into production and we observe how it behaves, we have an opportunity to capture new training data that might reflect a change in the world. The input data that's coming at us looks somewhat different than the data we originally trained the model with. And so there is this kind of feedback loop that's necessary to maintain over time an accurate machine learning model. And so inference data that's coming at the machine learning model is an important aspect of being able to capture what's materially different in that inference data and make sure that gets reflected back in the training data set. So that's an activity that is part of the feedback loop, and go back to the objectives of DevOps, and the objective of MLOps here is to be able to leverage that feedback effectively. And that's actually quite difficult. It involves management of large sets of data. It involves some really good data analytics capabilities, but doing that is part of realizing the vision of MLOps. And it's a very important piece of this puzzle. So differences in the development process and tooling for machine learning versus a traditional software application. So machine learning data scientists, people who work on building and creating machine learning models, often, not always, but often use more of a notebook paradigm for their development experience. And what notebooks do is really enable the data scientists to do some of those tasks we're talking about, which is, where do I get my training data from? Do I need to do some manipulation of that data and then feed it through a framework for training purposes? And when I get my model data out of that, then how do I test and verify that that model is now creating predictions in a good way? And a notebook application allows that data scientist to sort of do that all in one IDE that's kind of optimized for those kind of tasks. So you can repeatedly work on, okay, I massaged the data a little bit, I retrained, and now I see what my outputs are, and they're more accurate or less accurate. And so there's this internal iteration that goes on as you're building an ML model. And a notebook is a way of doing this. Now, what does this mean for DevOps? Well, notebooks have a little bit different like repo and sort of code storage process. Some of them sort of stuff that data into GitHub or some other code repository. You can do certain automation against those, but that code looks very different. And essentially, if you're using this kind of paradigm, you can't use all of the standard DevOps tools that you might use in the same way that you would for a traditional software program. The other reality is that most data science happens in interpreted languages like Python or R, as opposed to compiled languages like Java or C++. And that means there's a little bit of a different sort of file format. You've got a little bit different issues to deal with during build processes. So it's just useful to be aware of, and you're going to see a lot more Python in particular when you're talking about a machine learning component. That also means there's different tools that are used and frameworks and libraries that are integrated into these applications. So again, PyTorch, TensorFlow, these kind of frameworks are used to accomplish the training and are used for the algorithms that are used internal to the machine learning model. You got to manage those just like dependencies. So those are like any library dependency. They can't have defects in them that have to be updated. They can have security challenges that have to be updated. So that code base has to be managed. The next item that's a little bit interesting is this is an area that DataRobot in particular has a great deal of strength. There are several other companies that do this as well, but there is something called AutoML, which AutoML essentially is the ability for a tool to take that training data and determine which algorithms to use optimally to create an ML model out of that data. And so it sort of takes away some of the manual effort and iteration that a data scientist might do in a notebook, for example, and basically produces an optimized ML model out of a set of data. So this code winds up looking entirely different than notebook code. It doesn't behave like an application or a traditional software application. It usually winds up being either a binary that's produced by the tool that actually has input-output kind of protocol, or it's a jar file or some other sort of intermediate code, but not source code. And this thing then becomes part of your overall application, and that you've got to deploy this. It has to be operated and run. It has to provide an API that the rest of the application can interact with. So these things look a little different. And again, it mainly impacts the build and deployment sort of parts of DevOps. And it winds up being a little bit different process or automation tooling than a traditional software application. And then last thing, there are a bunch of tools that get involved in this process. Model evaluation tools being one of those. There's also something called like a feature database, feature evaluation. A lot of specialized tools that are used to help determine if that training and the model code itself are optimized, and understanding what's actually happening in that machine learning model. And that's very important from a regulatory perspective, and it also makes it more efficient for data scientists doing a lot of this, right? And so there's a bunch of different tools, development tools are being used there that we might always see. The last one I'll talk about, and then we'll kind of skip through, is model monitoring. And so in addition to traditional model monitoring, which you need for an ML application, so the first thing to say is this is all additional. It's not different, essentially. So you still need things like basic performance monitoring. You need error management. You need to identify sort of load on a component that's a machine learning component. So all the typical standard things need to be there. But in addition, we collect some additional data in an ML model. And so this data drives some statistical analysis around the precision of the model. How accurate is it in making its predictions? It also has some statistical models around data drift. And this is what I was talking about, where the real world data begins to materially change from what your training data set was. And as you sort of see that data change, you need to identify that. And so that's a monitoring activity and an alerting activity. When we start seeing a material difference in the inference data that's coming in and from the way that we trained that model, that's an activity where we need to look at and say, hey, this essentially looks like a defect. Like the model begins to produce predictions that are not valuable or incorrect. And we need to go back and retrain that model. And then the last segment is a really popular segment right now. And this kind of bridges over to governance. And it addresses the fact that businesses oftentimes are worried about machine learning because they don't know what it's doing. That, you know, it's a little bit black box, and that feels very dangerous and risky to many businesses. So part of the monitoring activity around a machine learning model is around understanding bias and fairness, and what is the data that's actually influencing the machine learning model's decision making, because it's essentially making decisions. Now, how we use those as a part of the application, we want to know if those decisions are being biased by a specific set of data. You know, prototypical example of this is if, you know, if the machine learning model starts approving loans for, you know, men and not women, for example, like we want to know that and say, look, that probably means there's something wrong with our training data, or the algorithm is misbehaving, right? And so it's really about surfacing what are the things that that model is making its decisions based on. Right? So these are important aspects of additional monitoring that are necessary to know if a machine learning model is working correctly, essentially. So big picture, you know, machine learning, model ops, ML ops, I think oftentimes looks like one of a component, sort of a variant component within a bigger DevOps solution, because you're making a big application. One component of that is an ML model. That ML model has some differences in its operations and its process flow. But it usually is not like a completely independent thing. And I think it's important to begin to look at how do you blend these together in the context of an application. I'm going to skip to the last slide. This one is simply to say the objectives of ML ops are essentially the same as the objectives of DevOps. Like for machine learning, we need to iterate quickly because that's what's going to give us the most accurate model. We need to identify defects, and there are maybe a different set of defects. There's all the traditional kind of defects, and then there are data defects that we need to be able to identify. We need automated and consistent processes, otherwise things take too long. And we need that feedback, and that's a critical aspect. So the goals are the same. The tactics are different. And so we have some additional tactics in the MLOps space around how we actually meet those objectives and get to those objectives. Right, so hopefully that gives you a little bit of an overview, a way to think about DevOps and MLOps, you know, side by side. I think they're not entirely different things, but they're kind of a variant of one another. Yeah, and with that, I'm happy to take any questions you guys have.
Feel free, folks, to ask questions. I have a couple, but I'll let everyone else go first, and hopefully have some time left to ask mine.
I guess I'll get us started. Ken, thanks so much. That was super interesting. I did have one question throughout the presentation, and maybe I'm reading more into this than I should. You seemed to indicate that the model data was something that you would deploy, that would be something that was more explicitly deployed rather than as part of, you know, as a result of retraining perhaps, and data drift, you know, response to data drift. Can you speak at all to the wisdom or non-wisdom of deploying an application that updates the model data dynamically, you know, without, say, a CI/CD intervening?
Right. Yeah. So I think the challenge there is, and I think automating the process of updating a model, which involves getting a different set of model data, is a really promising idea. But it holds these concerns, right? Which is, think about it from a versioning standpoint. So if I have a model and it's running in production, it's producing a certain kind of set of predictions, and we change that model data, well, oftentimes we want to be able to compare the new model data with the old model data, right? And so I think that conceptually, it's easier for me to think of the model data as part of the version of that component, right, along with the code. And in the same way that if you made a change to the code that was implementing the algorithm, for example, right, you might want to be able to compare that. And you also need to do some set of testing, you know, before you sort of roll it out. You may also want to do like incremental rollout. You may want to change that. So generally, I think of it as if you're going to do an activity that involves changing that model data, you need to be able to version that separately and deal with sort of what are how do I look at the comparison between the old data and the new data. And I think that's very important, particularly in like a regulated environment where those changes can actually change regulated outcomes. And you really need to be pretty careful about managing that change. Yeah.
That makes sense. Thank you.
Yeah. Yeah, I guess maybe I'll add really quickly. I would say that there's a lot of innovation going on in that space, but I have yet to see a really great solution for dynamic retraining based on inference data. And the reasons for that largely is that the inference data is so large, and it's quite a task to sort of sort out what of that inference data is going to materially change my training data set, right? And so that's a very interesting area of innovation that a number of companies and people are working on right now, and I think is kind of cutting edge or on the cusp right now.
Anyone else? Any questions? Please feel free to go ahead of me.
I had a quick question about this. Thank you for the presentation. This was really helpful. From a hiring standpoint, do you have certain thoughts around like how to best hire for an MLOps role?
Yeah, I mean, that's a really good question, and it's a challenge for a lot of companies. So I think a couple of the things I think about are, it's helpful to hire someone into MLOps that has a machine learning background, like they understand what a machine learning developer or a data scientist are trying to accomplish and kind of the tool sets they're using. So there's some awareness necessary. If they've worked in that role, I think that's helpful. But fundamentally, like the skill set needs to be a very similar skill set to somebody who's going to be building a DevOps pipeline, for example. It's really all the same sorts of skills and techniques for the most part. They just need an awareness of, hey, I'm serving a different user here in a developer that's working differently than a traditional software developer. So there's not a big difference. And it's interesting, you know, when I took the role with Algorithmia, Algorithmia was kind of presenting themselves as DevOps for machine learning. And I said, well, great. I know DevOps pretty well. I've learned a little bit about machine learning, done some studying. I want to learn more. You know, that was a good fit for me. And most of the people that I hired into that organization were people that you would hire into, you know, any kind of DevOps organization. They just had an interest or some insight into how machine learning works.
Got it. And just a follow up to that, because a lot of the models, like the general use cases of say computer vision or NLP, are being more and more, for the lack of a better word, commoditized. Like there's going to be like people who are actually like worked on that. There's good algorithms out there or the good models out there. Does having an MLOps person somewhat eliminate the need for having a bigger data science team as you draw that separation?
Yeah. No, I think this is I think it's important that we look at it, and companies that have been really successful with this, I think they were able to separate the notion of, you have data science, which is about creating the machine learning models. It's about, you know, the innovation and development of creating the models. You're right. There are both auto ML solutions and sort of stock industry models that can be leveraged to great effect and value by lots of different use cases. So you may or may not need a lot of data scientists because you can get the models that you need. And I think increasingly that's the case. The MLOps sort of portion of this, I think, is needed in all of those cases, essentially, which is you need people who understand how a ML model functions, how to operationalize it and put it into production, and the way that it's interacted and integrated into an application. And so I think that becomes a more durable sort of ongoing need. And it's a little bit of like a branch of a DevOps engineer. But you're right. I think in different companies and in different use cases, you may have a lot of data scientists or you may have very few. And you can still get a lot of value out of ML and machine learning in your applications.
And so that is particularly because that's why you want the MLOps people to have some background in data science or machine learning, because they need to be able to pick the right type of data, figure out how the feedback loop would work, so on and so forth. Right?
Yeah, that's right. And also consider those differences in monitoring that I talked about. So if you're going to operate the production system, you need to understand what is that other data that we're collecting, and how does that, what kind of tools does that need to flow into, and what is it used for? Yeah.
Got it. Thank you.
Hi,
Thank
Ken.
you.
I may,
Go ahead, Sudeep.
my name is Sudeep Ghosh, and I'm actually close friends with Mohammed. I've known him for like 20 years now. I didn't know he wasn't going to be on the call.
Cool.
But thanks for the wonderful presentation. The slides were really helpful. I just had a quick question. Could you provide any insights into if Amazon AWS is doing in something similar to the MLOps space that you're talking about? And what would be your insights or any thoughts around that?
Yeah, sure. So yeah, the way I would look at this, the way I see the market right now is all of the cloud providers, so AWS, Azure, Google, all of them provide various tactics in that kind of tactics list that I talked about, different parts and components of the overall sort of MLOps solution. Some of them are very good, and they're certainly optimized for that cloud provider, right? Generally speaking, they live in the middle of the DevOps space, though. They do deployment, they do production scaling, integration to a certain extent within the application. What they don't generally provide much around are kind of the front end tooling around training and evaluation of a model, for example. So if you're doing actual custom data science, you're probably using a different tool set that's not provided by the cloud provider. And on the other side, they don't have great monitoring capabilities for production models and looking at all of those different monitoring pieces. They have solutions, and they are beginning to evolve those, and probably will continue to invest. But generally speaking, I would think of it as cloud providers provide elements of your overall MLOps solution, but you're going to have to add some additional stuff and tie them together. So there's work to be done to kind of build out that. The vendors outside the cloud providers have tended to try and provide more of an end-to-end or complete solution that sort of covers all those pieces of the DevOps lifecycle.
Thank you, Ken. So just to then kind of summarize it from what I understand is it's in an evolving space right now as we speak.
Yep.
And especially, I mean, I think the big corporations are able to create a much bigger hype about their offerings versus what's already there in the market. No, thank you. I really appreciate that, and thank you once again.
Ken, one question I have
Go ahead.
is regarding the hiring process. I believe Rajat brought it up. Extrapolating on that, we're also looking to hire people with MLOps skill, but then we also always go with the idea that how really does it fit in? Isn't it just a DevOps role? Can we just get away with it or not, and stuff like that? And thank you for clarifying that specific need of somebody having a need or understanding of the data, being able to retrain. My question on that would be, for my clarification, for my understanding, is that would any certification out there in the market that we should look for from people? Because I know our team is not really, that in depth with these kind of technologies. But would any certification help in mitigating some of the items?
Yeah. Unfortunately, I'm not aware of, a good, clear sort of certification that would give you an indicator that somebody had that set of skills. I think it's still fairly nascent and evolving, and so I don't know that we've gotten to a place of having really consolidated around that. I guess what I look for when I'm hiring engineers that are work in this space is someone who's done, either significant coursework in machine learning or have done post-grad a machine learning training, certificate essentially. And so there are several of the universities provide, online machine learning courses that give you kind of a basic certificate in machine learning. And I think those are good indicators. Say, hey, somebody has actually spent a little bit of time really understanding the differences in how machine learning models function and how they're built. And that's going to give them that background to help them sort of have a little bit more understanding of it. And by the way, I would point out that this is not only for DevOps engineers, that like you want to hire DevOps engineers that have some familiarity. I would argue that increasingly the application developers that you're hiring to build your applications that are going to leverage a machine learning model also need to understand like what is a machine learning model and how did it get to be where it is, right? So it's kind of a broad industry thing where this becomes something that more and more of our technologists need to have a good awareness of. They don't need to all be expert in it, but they need to understand the differences.
That's what we're doing on that. Currently, we have some application developers who have shown some acumen to do some scripting or just transforming them into an MLOps role. I don't know whether that's a good idea or not. What are your thoughts on that?
No, I think I think that is a good idea. And I think, you know, that being able to have a little bit of mobility between those different roles and build some experience in those, I think it's as good as you can do, because there's not a single like clear training system or program that you put people through and they come back out and they have all these skills. It's something that people have to work with. And so I think cross-training and some mobility within your organizations is really useful. Yeah.
Thank you.
And one question I had is in terms of like GPU instances and things like that. Once DevOps, I mean, machine learning is into the picture, DevOps engineers need to set up a separate pool for training instances and, you know, have scaled that accordingly, maybe something on Spotinst or something like that to do that. I mean, I wanted to know your thoughts on that.
Yeah. So GPU, I mean, it's interesting. And this is an area where I've spent a fair bit of time looking at. We actually have a set of patented technologies around this, but utilization of GPU sort of capability for machine learning is really important for, you know, some set of machine learning activity. So computer vision to a certain extent, some deep learning type models. The cloud providers themselves, as well as a lot of the other kind of DevOps infrastructure, don't provide you a lot in terms of helping you efficiently work with GPUs, right? And so I would say that is another area where there is ongoing development. There's both some good open source projects. There's particularly around like, you know, how can a Kubernetes, for example, you know, pod actually leverage GPU effectively? But that is a place where you're going to have challenges and it's very expensive, right? It can be very expensive to use and leverage effectively. So I would go out and look for technology partners that have particular capabilities in leveraging efficiently GPUs. I believe that DataRobot now has probably one of the only solutions that actually provide what we call GPU packing, which is allowing you to actually run multiple models at once against the same GPU card. That is a patented technology, and it's something that took years to develop. So it's a difficult space, and yeah, you have challenges there if that's what you need.
Folks, just very quickly, I've posted a question about the next topic in the chat. If folks can just respond to that. But I have a very, just wanted to sort of elaborate on your answer to the previous question, Ken, just for the audience, as this will be recorded as well. So just a little bit about DataRobot itself and how it plays into the space. I mean, obviously, it's done really well from the point of view of VC and raising capital, but that is obviously a reflection of the company doing something interesting and successful. So we'd love to hear a little bit more about that.
Sure. So I think maybe there are two different areas related to what we've talked about here that are worth sort of pointing out. So DataRobot has really been one of the industry leaders, was one of the earliest, significant players in developing AutoML technologies. And so DataRobot has a very good set of tools around taking a set of data that a company might have and putting highly optimized, very precise models against that data without any direct code development. And they've really had a focus and been very successful at what we kind of alluded to here, which is empowering companies to get value out of ML without having to have massive investment in data science development teams and having to do the entire hard work of developing really effective machine learning models on their own. There's a role for that, for sure. But DataRobot's perspective has been that there is a lot of value to be had out of things that can be done through an AutoML sort of space. So that's kind of one. And they have a really excellent set of tooling and capability there to help get models in place that are super effective. Separately, they have an MLOps product, right, which is really about taking not only those AutoML type models, but custom models that your data science team have built, and providing all the tools and capabilities to work through the training process, do retraining, testing of those models, A/B testing and comparison, and then deployment. And in deployment, do all of the model monitoring, as well as doing sort of champion challenger comparisons and so forth. So they provide a really good integrated set of tools that help you see and observe that process and use the data that comes back to optimize the effectiveness of your machine learning advances. And the acquisition of Algorithmia was a big part of their adding to their high scale, high security production deployment capabilities, which is kind of the key area that Algorithmia brought to the table.
Got it. And just sort of a follow up, and I think to some degree you've touched on this as well, but you came from a background at Atlassian into Algorithmia that definitely was was perhaps a bit of a shift in terms of the focus. The companies do very different things. What did you in particular find interesting, or was there a spark that had gone off perhaps at Atlassian that sort of led to that?
Yeah,
I'm just curious about
well,
that.
the interesting thing is I'm working with the same customers, right? So in Atlassian, I was in a position where it was, had Jira and Bitbucket and Confluence, and it's really about corporations that were trying to streamline their DevOps processes and integrate those and have them be very secure and very capable. So all that same set of DevOps capabilities, really looking at that space. Machine learning, what I saw, and I sort of mentioned earlier, is that really all software development is moving to a place where it has a machine learning aspect to it. And recognizing and having a deep connection to the requirements and the necessity in an enterprise environment of a DevOps solution, I understand what those requirements are for machine learning as well. So that was really the bridge. The other thing was just simply a personal interest in saying, like, machine learning is very interesting to me. It's a different paradigm in terms of effectiveness of what a piece of software can do. And I really wanted to learn and put my hands on it. So it wound up being kind of just a cross-training issue for myself as well, saying like, this is a part of the industry I think is important. It's an area of technology that's interesting, and I really wanted to be immersed in that.
Fair enough. Thank you, Ken. And if anyone has any closing questions, please go for it.
Thanks, Adik. Hi, Ken. Thanks a lot for the presentation. Quick question from my side. I mean, one, I'm a huge advocate of MLOps. At the same time, knowing data science projects are typically non-linear, right? The amount of experimentation, the chances of it getting derailed is way, way higher. You know more than me about it for sure. Now, in that context, what would you recommend? Like, for me, MLOps is when you're ready for build and deploy, right? Any thoughts from your side of?
Yeah, I think, no, it's a great point that you raise, that the development process for a machine learning model is highly experimental and iterative, right? Whereas in traditional software, iteration happens, but generally we try and do, planning and upfront architecture and design, and then we implement it, and then we sort of harden it and deploy it. In the ML model sort of space, it's like, that's never going to happen. You have a thesis or a hypothesis, and you take a set of data and a set of algorithms, you begin to try and prove, is that hypothesis accurate? Can I understand it? Right. And so it's a very different kind of activity at the development phase. The way I look at it, though, is I think you want to draw a line, and you want to, on one side, empower those data scientists to do that iteration and be unencumbered as much as possible by downstream sort of complications. Once they get to a point where they have a functioning model that meets the hypothesis in some fashion, then you want automated sort of MLOps capabilities that can take that all the way through the process to deployment and use and integration, right? And so I think you're right, there's kind of a break point. Experimentation takes place, you want to stay out of their way and empower them to be as efficient as they can. And then once they get close and you're going to integrate it, then you want the rest of the discipline around a real sort of MLOps capability.
Yeah, that reminds me a lot of, honestly, even in software development, when you're iterating on an MVP, that nonlinear aspect does exist, and that's you can have very hard DevOps processes in place at that point in time. So it's not entirely dissimilar when you're in that space.
That's right.
As well.
No, I think semantically it's similar to those kinds of applications that really lend themselves to that sort of iteration where you're doing really greenfield, something brand new from a technology perspective. You need that freedom to iterate and so forth. Really, any custom ML sort of development effort is going to look like that essentially.
All right. Thank you, everyone. I know we've run quite a bit over, but thank you again for staying. And this was really awesome. And thank you, everyone, for the questions. Really, really good questions. Appreciate it. And the next mastermind is actually going to be on Rust, because we've already set that one up. But I will take the suggestions as far as the February and March masterminds are concerned. So thank you, everybody.
Thank you very much.
Take
Thank
care.
you.
Bye.
Thank you.
Thanks a lot.